All right, welcome to Birmingham Elixir. People are saying it's like the Austin city limits of remote Elixir meetups. I am Kevin Brown. We have Josh Adams and Oliver. We kind of help organize this every month. You'll see our faces. Sometimes we trade off responsibilities. And today we're doing lightning talks. So these will be just some kind of quick fire topics, and I'll let people hand off to each other. First, we have Anderson Cook with keyword versus map comparison. Next, we've got Ben with entity component system ECS pattern. And then Patrick Carver will finish it up with obscure but handy Elixir functions. So Anderson, if it's okay with you, I'll pass it off to you. Okay. And when you're done, you're welcome to do Q&A. It's not required, but just take it at your own pace. And if Ben makes it in, hand off to Ben. If not, we'll just save him for last.
Okay. Everybody can see my screen. Good to go.
Indeed.
Sure. All right. Awesome. Okay. So this is, and I don't know, it decided to start off with me. So this is a brief history of keywords and maps. I'm going to kind of walk us through some of the history of Erlang prop lists, Ruby keywords, get into maps, do some benchmarks, and then I'll do a lot of complaining. So a little overview. Erlang prop lists are pretty cool. We don't make a whole lot of use of them in Elixir, though we could. Some Ruby stuff, because why not? Elixir's keyword, and then we're going to drag keyword through the mud because it deserves it. We're going to do some benchmarks comparing map and keyword and prop lists and kind of their performance. And then a conclusion where we can all agree that I put a lot of effort into this, if nothing else. All right, prop lists. So Erlang doesn't have keyword lists by name, but they do have prop lists, which are even more dynamic. Values can be tuples or just atoms that represent the key and true. And it doesn't require keys to be atoms. They were introduced in 2009, and property lists are ordinary lists containing entries in the form of either tuples, whose first elements are keys used for lookup and insertion, or atoms, which work as shorthand for tuples, the atom and true. So prop lists can provide a key mapping to rename keys. So if we have a prop list where the key is bool and the value is true, we can run a function called substitute aliases, pass it a mapping, and just change the name of the key. And we can also provide a key mapping to rename the keys and negate values at the same time. So if we have a positive true, we can use substitute negations, and we can map positive to negative, and then we get out negative false. And we can also generate options based on values. So if we have a prop list with A and then D, and we call expand, and so the way to read this is we're looking for A, and if we see A, we are going to basically expand and include these other options in there. So we have a list with A in it, and at the end we pull it out, and we have like an even bigger list at the end with kind of like more options. So you can think of this as, if they pass in one value, you might have a lot of defaults that you want to put in there, or other things that you're kind of hiding through your API. And if the key is not found in there, then the prop list is just returned unexpanded. And then you can do things like normalize, where you combine all three. So we're used to using prop lists for ets tables and not a whole lot else. So we can say that we've provided a thin wrapper to the ets table for some reason, and we're going to say, pass me not write concurrent, but still name table duplicate bag, and I know what to do with that. So our first step will be to expand that. When we see that key, we'll expand it into not write concurrent, give the table a name, duplicate bag. And so when these are atoms, they're all true, of course. And so then we're going to have the aliases. We didn't like the give the table a name key, so we're going to rename it to name table. And then we're going to negate not write concurrent to write concurrency. So not write concurrent true is write concurrency false. And so Elixir is obviously inspired syntactically by Ruby. And so this is where we start getting into like keywords and their use. And so I'm not a Rubyist by any stretch. And so this is all learning for me, but Ruby supports keyword arguments, which give labels to the arguments as opposed to positional arguments. Missing a required key when calling it would give you an error. You can declare defaults in the argument list. So here, X defaults to 1 and Y defaults to 2. So you can call it with no arguments in this case, or one or both. and then the order doesn't matter. So I can do Y first and then X. And a warning if a key is duplicated on a call, it'll just use the second value. It's a syntax error if you have the key in the definition twice. And you can also pass it a hash map instead of a keyword. So keyword in Elixir was introduced in 2012 or earlier. It's hard to tell. Keyword list is a list that consists exclusively of 2-element tuples. The first element of these tuples is known as the key, and it must be an atom. The second element, known as a value, can be any term. And keywords mostly use a word for optional values. And so with keyword, there's a ton of syntactic sugar on there. So we start on the left, and we see that it's a list of tuples. And the first step to making it prettier is to kind of remove the tuple element and just have the name colon the value. And then when it's the last argument to a function, you can even remove the brackets. So if this is what it might look like to write it in Elixir. So if you have a function, you can define it with the keyword in there, but we can't implicitly create keys or defaults, and the order does matter. So if we were to call the first function with Y first, we'd get a function clause error. But if we want to approximate what Ruby does, we would need to default, our argument to an empty list, and then we would have to call keyword .get on these things, providing like optional values. So with keywords, keys are not unique. Duplicate keys are deleted after certain operations, but not always. So in our first example, we have a list with duplicate keys in it, and when we merge in the second one wins for that value. But if we flip the order around, we'll see that we have all the duplicates that come in from the second one. Keys have to be atoms, except when they don't. So with keyword split, we're going to pass it a keyword list where the first key is a map and the second key is an integer. And we're going to pass it a list of keys that we want to get out of it, in which case it's a map. And so keyword split will happily split the list apart for us, giving us the map key in one list and then the integer key in another list. And do we even need keys? So keyword merge will take a list and it'll take a character list and it'll give us back our character list if we provide an empty list. If we give it a character list to keyword.put, it will happily create that pair and then spit out the rest of the character list for us. Here are keyword functions that you can't pass a regular list. Keys and new will give you an argument error. Keyword functions that you can pass a regular list. Delete first, drop, equal, fetch, get and update, get lazy, get values, has key, merge, pop first, pop lazy, put new lazy, replace, split, take, update, and values. Map was introduced in 2014, and it is the go-to key value data structure in Elixir. It's there in the docs. They are internally represented as a list until it reaches 32 elements, at which point it's converted to a hash array map tree, but I'm not smart enough to go into all that. So let's compare performance of the things that are most similar, keywords and prop lists. So we have keyword get and we have prop list get value. So we're going to generate a list from A to Z, and we'll benchmark getting the first, middle, and last value to see how we go through the list, how performance degrades. We can see that keyword is generally faster than a prop list. And this is because keyword calls built-in functions written in C, BIFs, while prop list is regular Erlang. And we see that the performance degrades faster for prop lists as it searches more of the list. So keyword degrades a little bit, but we can see that like by the time we're at the tail end of the list for a prop list, it's half as fast. Right. And so then we'll just compare keyword get and map get. And we can see that map is faster and that it degrades slower than keywords. And then the size of the map here the internal representation should be lists for both of those. Why I started thinking about this again is that we have a place where we're doing a lot of logging on connections and requests that come in. And so I saw that we were building up a keyword and we were putting all these keys in there and we were merging all these other values. And then we were converting it into a map, and then we were going to JSON encode that. So I wanted to know what the results would be if we switched map.put and map.merge. And I don't think I can see my chat, but does anybody want to call out, is it faster to use map? Is it slower? Like how much?
In this example, I'm going to assume that it will be something on the order of like 8 times faster to use map.
Okay, cool. All right, so for this comparison, we're not going to convert it to a map or encode. We're just going to say like, build up a keyword, build up a map, use the same operations for both. And we do see that it is like 8.5 to 9 times slower to build up a keyword, and it uses 6 times the memory. And once we convert it into map, the thing we were going to do anyway, it's additionally slower. And so when I ran this, when I was benchmarking this off our code base, we were running on OTP 23 at the time, and it was 40 times slower. And then when we switch to OTP 24, it's, the JIT is magic. So we saw like much less, like, it was more, there's more parity. All right, so why is this slower? So let's look at keyword.put. So the definition is here, and this is what it does. It prepends the pair, and then it iterates over the rest of the list, duplicating or deleting any duplicate keys. So keyword delete first checks if the key is in the list with a BIF, and then recursively deletes instances from the rest of the list. So if the key is in the list, so it does a check, is the key in the list? And if it is, then it's going to like iterate again. So once to check and then another to delete. And then map put calls it BIF. And then we have keyword merge. So if either of the keywords is an empty list, it's just going to return the non-empty list. And if not, it's going to iterate over the second keyword and check that it is a keyword, basically checking that it's a tuple and that there's a key that is an atom on the first part. If that succeeds, it's going to create a function where it's going to be used to filter the first keyword list by looking at the second keyword list and checking if the key is in there. So it iterates over each element of the second list to check that it's a tuple with an atom key. It creates a function that will check if the key is in the second list for each key in the first, which is calling a BIF. Filters the first list, which is a list comprehension, and concatenates the second, which is a BIF. And so it iterates over the first list once, and then the second list 1 plus the length of the first keyword, and then map.merge just calls it BIF. So in conclusion, prop lists are kind of cool. The rules about keyword keys are derived from the syntactic sugar, just so that we can have it look pretty in our editor. So it's Ruby syntax without the rest of the good stuff that Ruby gives us. Keywords do runtime type checking when it feels like it. It allows non-keywords most of the time. If you're interested in maintaining duplicates, you'll probably avoid the keyword module, or you'll know exactly what functions delete keys and which don't. And if you want duplicates, then a map will be faster and have better guarantees. And so maybe we sprinkle the sugar on maps instead of keywords. That's it. Thank you.
Great. Loved it. Thank you. That was really good. Cool. Patrick, are you ready?
Well, no, but I'll do it anyway. No, I'm ready.
Take the baton.
Yeah, let's see. Share my screen. All right. So my talk is over. Of course, I built it as handy but obscure but handy Elixir functions. Now these, I may have oversold the handy part, but these are kind of a couple of I've kind of run into that people don't seem to be too aware of. That may be a good trick to have up your sleeve. So what I'm going to go into is, well, first I'll introduce, we all know our good friend pattern matching. So we'll say it's Y. Get that. But did you know in the kernel method, there is this thing called destructure. So we can do And we're going to, now we can do the same thing, but and we get 3. Now, if we were to try to do the same thing, just regular little pattern matching, do that, and it's going to say, nope, can't do it, did not match. So the structure allows us actually to have on the left-hand side, we can have, say, 3, 2, however many, and we can have a variable list on the other side. So you may ask, okay, well, what happens if, let's say our list is only 1 long, but we have 3 variables? What happens? We just get nil. No errors, nothing like that, just plain on nil. So is this useful? I don't know. Could be, but it was interesting. I saw this on Twitter the other day or so. It kind of sparked my interest. So it's like, oh yeah, there's a thing called destructure. So we were finding stuff for pattern matching, and maybe you're getting some input that maybe you don't know the length of, and you want to do some pattern matching. You know, at least on the first 3 or 2, you want to match on. You can use it like that. So something to keep in your pocket. So, and this one is, so number 2 I was going to show is, if you ever done advent of code, which is if you're not familiar with, I'm sure a lot of you probably are, but in case you're not, it's a coding contest in December, runs through the 1st to the 25th, and each day there's a coding exercise, and you're given some input. And I've seen a lot of people not familiar with this particular function is, and a lot of advent of code problems have you, okay, here's a bunch of numbers, here's some input, do something with it. So there's a few times where we've done like a real long number, and you need to split it into integers. So this is an integer. So some people will convert this to a string that they'll map over and do a string to that integer like that. But you can skip that step, and you can say integer to digits, and voila, you get your list of digits right there. And what's really extra fun is there's integer dot undigits. So I just love the name of that. Undigit switch versus the process. Could be handy, especially when you're trying to do advent code. And lastly, and probably least, is one thing I've run into when I was kind of looking over things. There's also in the kernel module, there's a thing called binding. So if I want a list of, so in my IE section, can I get a keyword list of all the variables I have? So it's going to list X, Y, and Z. Now, it's not specific to IEX. You can use this in a module if you want to, but if you've, especially like me, if you do a lot of REPL programming and you want a list of any functions you defined, this whole list, so I can find, so let's say equals this or these. Okay, combine it again, and we have it in our list right there. And we can also create a context as well. So I'm going to call it ham or context. And I'll set this to do it like this, and that's not it. And you know what? Never mind, because I forgot. So anyway, binding is nice little tool, just especially if you're if you just need a list of all of your variables you need. And that is my list of marginally handy, obscure Elixir functions. So there you are.
Great.
I had never
Thanks, Patrick.
seen any of these,
Yeah.
and I read the Elixir docs for fun. So congratulations, that's awesome.
Well, thank you. Yeah, I saw a few of these, and what is interesting, like I said, I saw the destruction one on Twitter, and then I think Oliver kind of came, is like, hey, you want to do some hunting talk? Like, well, yeah, I can do that. So I kind of looked for a few others I remembered. So those are a few I had offhand.
That was good. The advent of code is a good call out. I remember using digits and undigits quite a few times. Cool. Well, I think that's all we have for today. Thanks again, speakers.